Hi folks, Mr. Sonnenberg here. Today we're going to be talking about specific heat capacity. So what that is it's a substance's ability to absorb or to lose heat. So absorb meaning to take in and collect, and lose to mean to get rid of heat. We measure this in joules per gram degrees Celsius. So in saying that 1 gram of water is going to absorb 4.19 joules of heat in order to raise its temperature by 1 degree. And the same is in the inverse. If we're going to 1 gram of water is going to lose 4.9 joules of heat to lower its temperature by 1 degree Celsius. So the formula for specific heat capacity is Q equals mc delta T. And so what that means is the energy transferred is going to equal the mass of the substance in grams multiplied by the specific heat capacity, which is your C, and then also multiplied by the change in temperature in degrees Celsius. So what I have here is an example problem that I'm going to run through with you. I'm going to get you to actually pause the screencast and see if you can answer this on your own using the previous formula um, on the slide before, or just slightly before this slide. I just want you to try this out. So I'm going to pause it, and then I'm going to come back and I'm going to actually complete the problem. Okay, perfect. Hopefully you're back here and you've done it. Let's see if yours matches up. So the first thing I need to do is I need to write my formula. So down here what I'm going to write is Q, oh I'm struggling with this writing, equals mass times specific heat capacity times delta, or change in temperature. Now I'm going to list what I know. So Q, do I know my specific heat capacity? No. My mass in grams is going to be 200 grams. My specific heat capacity of water, there's a chart following this. You can use the chart in your textbook if you didn't know the specific heat capacity of water. It's actually 4.19. Okay, and then we're going to take our change in temperature, and it's going to equal 10 degrees Celsius. So now what I'm going to do is plug this into my formula. So Q equals mc delta T is going to equal 200 grams times 4.19 times 10. Okay, so it's going to equal, well, first I'll start with this, 200 times 10, 2000 times 4.19. Try not to use a calculator here, so we're going to get 4.19 times 2, it's going to equal 8, carry the 1, 2 is 3, and 2 is 8, 2 decimal places, 8.38, and then we're going to add a bunch of zeros to it, so it's going to be 838,000. That's what our specific heat capacity is going to be. So it's going to be joules per gram degrees Celsius. Okay, so that's how we figure out and we determine our specific heat capacity. We have to take our mass in grams, so we have to multiply it by our specific heat capacity of that particular substance, and then we have to also multiply it by the change in temperature. And so in this case we had 200 grams of water, its specific heat capacity is 4.19, or its specific heat capacity, so we're going to actually be determining the amount of energy that's transferred, and then it's also a change 10 degrees Celsius. So excuse me, in order to change the temperature or change the heat transfer of that amount of water, that's the amount of joules per gram degree Celsius, our specific heat capacity of that water. Or not specific heat capacity, the amount of energy that's transferred, sorry. Okay, so hopefully this matched up with what you had done previously. If it didn't, hopefully you can figure out why it didn't. So, moving on, all I have here now is a chart for specific heat capacities. Just a list of different substances that you'll find. So water, its specific heat capacity is going to be 4.19. Motor oil is going to be 2.00. Vegetable oil 1.97. Air very low at 0.995. Glass even lower at 0.84. Sand 0.66. Iron at 0.45. And then copper at 0.38. So if I was to take 100 grams of water, 100 grams of glass, and 100 grams of iron, which one would have the lowest specific heat capacity? It's going to be the iron. Now, say for example, I know some of you have, probably everyone here has gone to the beach. When you walk on the beach on a hot day, the sand, what feels warmer, the sand or the water? Well, the sand feels warmer, okay? The water still feels cool. The reason for this is because water's specific heat capacity is higher than that of sand. The lower the specific heat capacity, the easier it is to transfer energy. So that sand is going to absorb more heat than the water is, and it's going to feel warmer. So the same thing kind of goes, if I was to take 250 milliliters of water and 500 milliliters of water, and I was going to, in that, I was going to um, boil them at the same time, or not boil them, sorry, put them in the fridge and then take them out, which one would reach room temperature faster? The one 250 milliliters, the one 500 milliliters? And the answer is actually the one at 250 milliliters because it's going to end up having, they have the same specific heat capacity, water does, but because there's less of one substance, it's going to heat up faster. So it's an important concept to remember. Anyways, folks, that's specific heat capacities. Hopefully you've learned something here and it'll help you in your post assessments. Okay, thanks. Bye.